I'm gonna try passing only the attributes. Okay, so this makes sense. Then for the source, oh, I don't need the keyword argument. Why didn't anyone tell me? There's no attribute context. Okay, this makes sense. This definitely needs to be passed in. So normally you pass in a shader. I think instead of the shader, I'm just going to pass in the context like this. I think that's the easiest way to do it. Since it's reading that context from the shader, even in the superclass. Okay. And I'm missing an argument for attributes. The context, the source, and the attributes. This shouldn't be self dot. This should just be the one that's passed in. I wonder why I would be missing one argument. Oh, I just didn't save it. I think I just didn't save it. Okay, so that worked. It just didn't do anything because I don't have an embed here. So I'll put that there. Run it now. I see nothing. I successfully see nothing. So now the question is, if I already have this color, how can I edit the attributes? Actually, there's a different problem here. If the shader doesn't exist, the shader doesn't exist until after this is initialized. So I'll have to initialize it. At the time it's initialized, then that shader will be created. And then I can set the attributes, set the uniforms on the shader. So I'll have to do like, this isn't actually a problem, but I'll have to do surface dot shader dot set uniform whatever. And I will have to set a few uniforms. So I guess it's good I can do it that way. I'm going to try setting the uniforms now just so I can make it show something. So those two, and I think that's all. I'll take the model view matrix and the projection matrix. After doing that, I think that's all the uniforms I need. And it'll only be the attributes. Should only be the attributes. Okay, see if this works any better. Okay, so now it works the same way as the other shader. So when these attributes get passed in, I need to override the invert attribute. This has to be the entire screen. So the situation will be the user won't pass in the invert attribute at all. The attributes will just be like this. It's just like some attributes, some other attributes listed. So then when you try to run it like this, there's just nothing there. So I have to add to those attributes. So I'll basically have to recreate them like this, but do it programmatically. And then after that, I'll copy all the attributes from the shader that the user passes in. So one question would be, I just have to get the length, and then how do I get all the data types, the names of the data types? I think that won't be terribly hard. Like if I put a breakpoint here, and something broke. Cannot, oh my gosh. Yeah, my integrated terminal just got Rect. Oh well. Going to have to close that. Save all of this. Rect. Oh well. Going to have to close that. Save all of this. And then close it. Yeah. Are we back? Don't know why that happened, but I'm gonna try just printing. Self dot. Actually, full screen. So I pass the attributes here. I definitely have to save those. So I'm gonna say self dot attributes. Attributes. Okay, then here I can do self dot attributes dot size, I guess, is the way you do it in NumPy. And the point of this is to get the number that I'm going to be editing later. So I guess size is only one dimensional. It's just that 6, which is good. That means I can just put self.attributes.size. Actually, yeah, I think size is what I want. I want to make sure it isn't shape. The shape will give like the dimensions. So in the data type, I think I can also get from... I can try it doing using the debugger again, but this time I'm going to comment that. Oh, this didn't even run. I guess I have to self.wait or something? Okay, there we go. Now if I do self.attributes dot dtype, I think. Okay. I guess that isn't... Can you just index this at 0? Kind of. Like, how do I add to this data type? I want... Can you do, like... Here's the NumPy documentation. I can't believe I don't have this opened. How can I add to one of these? If an array is created using a data type, the dimensions of the subarray are appended to the shape of the array when the array is created. That doesn't help me at all. Okay, the titles can be any object, but when a string object will add another entry to the fields dictionary keyed by the title. Okay. So I guess I can use this dictionary. I can use a dictionary as an input to numpy.dtype. Okay. So if I have numpy.dtype, then I can pass in a dictionary with well, first I have to match the names to the actual data types. So I have self.attributes.dtype. Is it like names or something? Okay. And I want to match that with the data types themselves, which I think is just when you index the data types list. Or maybe I can just do dict of the data type. Whoops. Nope. Oh, not at 0, but that's Nope, still can't do that. Darn. If I could decompose it into a representation that can be easily edited. Can I do dict of the names? Name. Can I do dict of the names? Name. Names? And the data type itself. But I think it would have to be zipped. Actually, let me see what the zip does in the first place. No, can't do that either. At least this is a common problem. It seems like you can from this, but the only reference to it is here. Add another entry. What's the example it's using? This is a dictionary where names is all the names, formats is all the formats. Can I get the formats? Nope. Oh, dtype dot formats. Dtype at 0 dot format. So I can get the name. Kind of. Void 128. Wonder what kind is. String is? I feel like this is a lot harder than it's supposed to be. I guess the other option is you could have the user specify their data types up front. And I feel like that'd be pretty annoying on their part. Yeah, I don't know. For now, I'm just gonna have, I guess, have the user pass in the data type with the vertices. So I guess I'll have to pass that in on their own, since I don't know how to edit it. So if it's done this way, okay, now it should work the same way it always did. Fine. And since I couldn't figure out a way to do that, let's have this. I'll just do a to add this attribute to be full screen. Since you wouldn't want the user to have to do pretty much setting it full screen manually. I have the code to do that somewhere here. Because the user shouldn't have to type that out. Okay, at this point it should be full screen. Great. And then you can use whatever fragment shader you want. Like the one I was able to get working last time. I think that was design 3. Then maybe we can just do like this. Nope, a different bug whip. Oh, wait, did I have to edit this some? In color. Oh, then I wouldn't want to set the color uniform. I wouldn't want to set the color, but I would have to do the resolution and the time. So I'm not going to do that right now. I'm just going to say, for now, this works this way. One day, I'll have the means to... So the user won't have to type out that invert data. But right now, I'm not going to try to figure it out. So the user won't have to type out that invert data. But right now, I'm not going to try to figure it out live. Well, that's fine. Next thing I'm going to try to do is improve the logic that the OpenGL renderer uses to convert mobjects into OpenGL meshes. And that would be pretty helpful for improving the architecture. This I'm going to... Which changes did I add? Basically added this and the shader example. I'm going to take out this last test case. And with this, I'll commit all of those changes. And this, I basically wrote the shader and the mesh. Okay. Next thing to do, improve that code in the OpenGL renderer. So I'm going to update my shortcut here. Do the shader example. Great. Then I'm gonna have to look here. So render mobjects. I'm gonna basically have to tear this method apart, which I foresee being pretty annoying. But this logic with get shader wrapper list, then I convert the shader wrappers into rendered groups, then render the rendered groups, is pretty confusing. And I don't think it needs to be. So let me start with this code. Render mobjects. It's going to get the shader wrapper list, and that's specific to the mobject. So I go to, for instance, OpenGL vectorized object. And let's go to its get shader wrapper list. It's going to import this shader wrapper class, then append shader wrapper, append a bunch of shader wrappers to these lists. Then at the end, combine these lists. And so I guess there'll be just a list of shader wrappers. Now shader wrappers are containers over a bunch of different data. Now, let's see. So it has vertex data, index data, vertex attributes, a shader folder, uniforms, texture paths. It's sort of like the mesh class that I had before. The difference being mostly that it's just a lot more complex. Well, and you can't set the attributes or the shader code inline. So let's see, a program ID. These are cached by program ID, uniforms, texture paths, depth test, and render primitive. So if all of those are the same, it'll reuse the shader wrapper. Well, the depth test, I guess this makes sense as a key. What I'm going to do is here, when it gets that list, I want to see if there's a better way, if I can instead convert it to meshes. So like this code, I want to see if there's a better way, if I can instead convert it to meshes. So like this code, instead of render groups here. And then from there it'd be easier to render the meshes. Okay, and then in order to create a mesh, I'm gonna need the shader and the attributes, which is fine. We'll start with the shader. The shader is going to be determined by the object, and it's the same way in this. Because when you get, for example, the stroke shader wrapper, I'll do a shader wrapper over this data, and somewhere it's going to have to read the name of the shader, though I don't know where. Oh, you know what I think it is? I think shader wrappers don't have information on the shader, but render groups do. So when I go to get render group, this creates the shader from the context and the shader wrapper, actually. So this must have some information on the shader. So when I go to get shader program, this will do this dot get program code. Program code, which returns self.program code, which is created in init program code, which is created in get code. Okay, so it comes from the shader folder. I didn't write this code, by the way. This is code Grant wrote, so don't like judge my super complicated code. Oh, I should have seen that comment earlier using list. I hope that doesn't work. I kind of hope it doesn't work, because if it does, then I would completely ignored that. If I do something like vert mp dot, I don't know, what's that, n32? So I think I can do it this way to create one. No, I guess it doesn't work. If I did x at 0, I guess that doesn't work either. Okay. You'll have to figure out those NumPy types later. Okay, so first things first. If I want to create a mesh, I'm going to need the shader. If I want to create a shader, I'm going to need basically the name. Okay. Now, given the mobject, there's sometimes a few different names you need that I'll need. For example, the vectorized mobject code has a stroke shader and a fill shader. Where does it pass the name of the folder? Shader wrapper is imported here, but it's not used. No, it isn't used here. It's only used in get stroke shader wrapper. Here, so the folder is called stroke shader folder. Okay, so that's where it's stored. I guess stroke shader folder is as good a name as any. Well, not quite. I'm gonna want to call this... I'll have something called shader names. I'm gonna want to call this... I'll have something called shader names. And then fill shader folder. Whoops. Since this needs multiple names, I'll say for shader name and mob.getShaderNames. And then here I'm gonna like create a shader from the name. Fair enough. So going to the mesh code, or the shader code. And so this will use a cached program by default, which is good. I'll say shader. The shader object that can give the self context. It's the context from the renderer, then the name will be the shader name. And I'm not totally sure this will work because... No, I think it will actually. Since it is just looking in the shader folder. Well, shader folder slash name. Where's the shader folder right now? Shaders? I think that might actually work. Let me see. Oh, I'm actually surprised that didn't just crash immediately. Oh, what I think happened is just that there's no objects to be rendered right now. So if I do C, it's a circle. And just add that. I think there's a decent chance this will crash. Yeah, no attribute. Get shader names. Which makes sense. Where did I call get shader names? Must have been in the renderer. So this is just shader names. Okay. No directory shaders slash that. So that makes sense too. If I look at Manim renderer shaders, I've been storing these shaders just like not in folders, which actually isn't good. I think the way it needs to have them is the name as a folder. Then inside that, it has frag geom vert.glsl. I guess that's fair. So then all of them will be called vert.glsl or frag.glsl. Okay, so how can I change the shader to search for it that way? Go to the shader code. now it's looking in the shader folder slash this. What it should be is shader folder slash the name slash whatever.vert and whatever.frag. Name.vert and name.frag. Actually, I don't want to remove this code. I'm going to, I guess it would be a flag, really. I'm going to have this flag for search method. I'll say search for folders. I'll default that to false. Okay, now if I run it, just so I don't break the test code that I have. This is when it's false. When that's true. So this will be an else clause. Now it's going to look in the folder slash the name slash